Hello and welcome back to another episode of InstaBlinks. I'm your host, Brian Graf, and today I have Andrew Mills, a Senior Solutions Architect here at NetApp Instaclustr with me to talk about Apache Kafka. Andrew, welcome to the show. Please go ahead and give us a little introduction about yourself.
Hey, thanks so much, Brian. Yeah, as you mentioned, Andrew Mills. I've been about 15 years in the technology space. Spent 7 or so of those years working with big data pipelines, specifically around Apache Kafka. I've been here with Instaclustr for about 2.5 years now.
Awesome. And you're the man for this show. You've worked with messaging platforms. You've worked with Apache Kafka for quite a while. And I've reached out to you personally on a few things. So I'm excited that you're here to talk about this. So for those who maybe don't know what Apache Kafka is or haven't worked with open source technologies, can you give us just a quick rundown on what Apache Kafka is and what it's used for?
Sure. At the highest level, it's a message system, right? So it allows you to stream messages in and then consume them from one to many potential consumers. We just released Apache Kafka 4, which actually introduces queues as part of a preview, which is a new feature within Kafka. But in general, it is a message bus message streaming platform.
Awesome. So I can think of a number of different ones out there. I think we'll get to this later on, of just kind of choosing what technology to use and why Kafka maybe is a good option for a number of people. Why is Kafka so important these days? We have quite a few customers that are running very, very large workloads through Kafka. Maybe you can tell us why some of our customers are doing that.
Yeah, that's a great question, Brian. So, we're in a connected world. It's the age of data and IoT and just overall connectivity. So, I would say that some of our customers are really tapped into whether it's logistics, like DoorDash, who uses us for food delivery. If you're talking about internal messaging, you're trying to monitor and manage other systems. There are so many different use cases, even fraud prevention when it comes to credit card transactions. So there are there are endless use cases because of the volume and velocity of data that everybody's trying to deal with.
Yeah. So let's maybe double down on that a little bit. So talking about, in the past, some of the monolithic architectures, as some of these applications are growing or the user base grows, right? So if we take DoorDash, for example, I don't know many people who haven't used DoorDash at one point in time in their life or some food delivery service. They have to be able to scale, right? And so I guess as we move away from like a monolithic type of an architecture to containers and really expanding out to be able to help millions of customers at a time. That's going to obviously become a lot more difficult to maintain, manage the logs, the messaging, the organization of any of the activity going on. So how does that work with Kafka? Is Kafka monolithic? Is it just like a single application that takes everything in and it's a big machine? Or is this like spread out?
Yeah, we could dive down this rabbit hole pretty deep, but there's a couple of things that you mentioned there, and this monolithic transition that's been going on for many years, and it's still, I would say, at the tail end of it, but it's still happening. Essentially, historically the idea was that you had one big application or API that you wrote all your code in, and maybe you had different classes or you grouped it in certain ways that allowed you to make it easier to manage. But then when it came time to deploy that, you were deploying the entire thing. And so, we're talking, 15, 20 years ago, they realized this is a problem. So we started this transition to what we call microservices. So in the microservices architecture, you essentially split up your monolithic application into a whole bunch of different services. And very quickly that became painful to deploy and manage at a different layer. It was easier to incrementally deploy little pieces of it and actually do code quality and all that stuff around each individual API or application. But the actual orchestration of the deployments became a lot more challenging. So one of the ways that Kafka can help, and we'll talk about Kafka's architecture here in just a second, but one of the ways that Kafka itself can help in that is it's essentially used as a message bus to do microservices orchestration. So when you have this big monolith that's been split up into 50 different microservices, when all of those microservices need to talk to each other, oftentimes people use Kafka to send messages to, and then the other service will pick it up, read it, do its thing, and then maybe it sends something back to Kafka, or maybe it sends something directly to the client, like a message on an app, or an email, or makes a phone call for them, or something like that. So we talk about the monolith to microservices transition. There's kind of the application and API side, which is what we just talked about. And then specifically, there's the Kafka side. So you ask, is it a monolith? So there are some data services, data technologies out there that are more monolithic. You think some of these, databases that it's just one server, and that server serves as a write and read replica, and that's it. Now, there's a lot of them that are moving away from that because that is really hard to scale. So Kafka was actually designed with the concept in mind where it was fully distributed. And that does a lot of things for you, but specifically, it makes it highly available, and it makes it very disaster. It makes it good for disaster recovery. So those are two really good benefits. Plus, the ability to scale and introduce parallelism in your writes and reads makes it really, really performant. And so in the particular architecture for Kafka, it is a distributed architecture.
Awesome. So then, as a customer's application continues to scale, right? Let's just come up with application X, for example. As it scales from 50,000 users to, a million monthly active users, or to 25 million monthly active users, Kafka can essentially scale out as well because of its architecture to support that, correct?
Absolutely. And the way that I think of Kafka is it's like your bloodstream, right? It's like the heart, and you still have to have the microservices on the outside that do the tasks. But Kafka is that central system that really allows all of the events to flow into it, and then you can use them to do other things on the outside. And so it by itself absolutely can scale significantly and allow you to scale your entire operation and all of the applications that produce and consume events with Kafka. So yeah, it is definitely infinitely scalable, I would say. Yeah.
So then let's maybe jump into the architecture now. We've talked a little bit about what Kafka is and that it can scale, but let's break down the actual components of that architecture for the listeners to kind of understand what all is involved and how that allows them to scale.
Sure. So Kafka itself has, I would say, two main components. First are the brokers, and the brokers are essentially where the messages are produced and where the messages are consumed. And then there's another component called the quorum controller, which basically just keeps everything in line, right? It makes sure that you have a good quorum for your brokers, and that it helps with leader election and understanding which ones are the replicas and all of that. And so the broker component is the heart of Kafka itself, in that it is what accepts the messages, writes them to disk, and then issues a command essentially to replicate those messages to what's called the in sync replicas. So anytime you write a message to Kafka, the default is a replication factor of 3, which means that the message that you send is going to be stored on the local disk, but then it'll also be sent to 2 other brokers in the cluster. So that's what makes it distributed. And the value in that is that it's a write ahead log. So that means that it's not going in and changing records. There's a separate process that handles deleting records. So it's just writing it in an append log. And so that makes the writes extremely fast. And then it can replicate those data to the other brokers, and then let the thing that produced the message let it know. It lets it know, hey, this message has been produced and kind of acknowledged, and you can move on. So from a producer side, it's really fast. And so that is the broker and the quorum controller piece. And so those messages are produced in what's called a topic. And so a topic is really similar to like a table, except the structure of that topic is not really defined in Kafka. There are schema registries and other things that you can use to define how your data is stored and this and the properties and schema around those data. But Kafka doesn't necessarily uh, require that, right? You're just storing bytes in a topic. So your topic represents your essentially your table, if you think in a database context. And then inside of a topic, you have what's called partitions. And so your partitions are where the parallelism comes into play. So you can spread out your data, and you can have the owners be spread among a lot of nodes in a broker. Sorry, a lot of brokers in a cluster, and that spread allows you to write data very quickly and read data very quickly from the consumption side.
Okay. And I guess maybe if you have a small application or you're just building out your architecture for this, your topics naming schema or naming uh, doesn't really matter too much. But maybe as you're building out, the naming of your topics will probably matter, right?
Yeah, I mean, look, besides dates, I think names are probably the most challenging thing in anything technology related, right? I can't tell you the number of times I've sat down and just racked my brain over what can I name this to make it obvious for future people or the future me, because 6 months after you build something, you don't remember anything about it if you've stepped away from it. So absolutely, naming matters a lot, and it matters for a lot of different reasons, but Kafka has a mechanism that allows you to use regular expressions if you want to like consume from a group of topics, and you have to just really understand the way that Kafka allows you to work with the topic names in order to pick good names to implement whenever you're creating your topics.
Topic names matter. Topic one, topic two, probably not the way to go.
I mean, if you're just starting and you got one cluster, one node, and you're just tinkering, sure. But yeah, for sure, once you're kind of at that MVP stage and you're trying to build something that may actually work, um, you want to take a little bit of time to think about it, because as we all know, uh, the temporary things that we do typically are more permanent than we'd like.
Yeah, yeah. Once you've made something in production, it's very unlikely that that ever goes away or is renamed.
Absolutely.
Um, so okay, so we've talked a little bit about the architecture. Let's maybe pivot here. If I am a solution architect or I have an application that I'm over at my company, and I am looking at a messaging framework or a messaging bus for my application, let's maybe walk through what that looks like to kind of design something based off of requirements. I think all too often we jump to the first thing that we're familiar with or something that we've heard the most. But at the end of the day, I think a lot of these applications fulfill the same end result, but maybe there's some intricacies there or reasons to use one over the other. And so for somebody that is in that position, going to build an application or architect for their application, what would you consider, kind of starting back at the fundamentals here of how they should consider building Kafka for the long term?
Yeah. So, in the space of data streaming, event streaming, the Kafka APIs have won. I mean, that's just that's just a fact, right? There are other systems out there. Apache Pulsar comes to mind. Azure Event Hubs comes to mind, where it's a different underlying mechanism. But like in the case of Azure Event Hubs, it actually has the Kafka APIs are implemented in there. And so the APIs around Kafka one, and the reason for that is because Kafka is the standard for event streaming. But it does not mean that it is the best for every single solution. And I am a big proponent of making sure that you choose the right tool for the job, because if you got a hammer, everything looks like a nail, and that's accurate. Plus, some people try to change the technology to work for a specific use case that's kind of an anti-pattern in the way that the technology was originally designed. So, there's a lot of considerations there, but in general, if you have a need to stream data in real time or near real time, and then um, make sure that those data are highly available and and you care about disaster recovery, um, Kafka is a really good choice for that. Uh, if you have a need for like queues, although that is in preview right now in Kafka, RabbitMQ may be a better choice for you, right? And sometimes you may not have a choice, So if you're using something that's got uh, a big financial integration, and you might be forced down like an IBM MQ path, right? But I would say that most, you know, logging use cases, data streaming use cases, event streaming, message brokering type use cases, Apache Kafka can really solve that problem for you, especially if you have a good handle on how to architect for the problem. Because there are some nuances with any sort of message streaming that, if you're new to it, can be complicated. And so, one of the things that I say most people don't think about is what happens if I get a bad message in my queue and I'm humming along at a million messages a second. Well, that'll stop the show sometimes. So you have to think about, how can I tolerate a bad message but not lose it, right? So there's a lot of considerations in there, but Kafka gives you the framework to help solve most of those types of use cases where you have a lot of messages coming in at a heavy clip, and you need to consume them, or consume them in with multiple different things that are acting on them, I would say.
Okay. And when you have, say, a million messages a second coming in, one of the things that comes to mind for me is the amount of storage I'm going to need, right? So I guess for a customer that's looking to implement Kafka, and they're looking at a lot of message streaming going on, what are maybe some of the considerations that they need to take around, replication, data retention policies, et cetera? How should that be tied into how they architect
Yeah.
their environment?
Yeah, great question. This is actually a really interesting question in the market right now. So there the idea behind data gravity is real. And so what that means is, data is expensive to store and expensive to move. And most data technologies require that you move the data into that technology before you can leverage it. So if you think about any type of database, you have to kind of write the data into that database before you can use it. And and then when you write it in there, you get indexes and stuff like that around the way that particular technology works. So Kafka is not any different. When you start producing messages into Kafka, what's going to happen is it's going to store those messages on the local disk that you have. And then, as we mentioned earlier, it's going to replicate those messages to the other disks in the cluster. And so the default mechanism for Apache Kafka is to store it on the local disk. And that can be an EBS volume or something like that. It doesn't have to necessarily be an attached SSD. And then after it's stored on a local disk, there's a couple different ways that you can get rid of those messages. You can either set retention policies to delete them after a certain time period, or you can set it to delete it after a certain amount of data has been aggregated. And so that will then delete it from the local disk. With KIP 405, which came out not too long ago, they've introduced the concept of tiered storage. So what you can do is you'll write your messages. Again, they're still going to go to your local disk and then be replicated. But then after a certain time, instead of deleting them, it can actually move those messages to like an S3 bucket, some sort of data tiering mechanism like that. And once the data has been moved, you can still read it from all of your replicas, but it's sitting in much less expensive storage. So that's definitely something to consider. Uh, but if you then have to, um, read it out of S3 or read it out of Kafka to put it into ClickHouse or a relational database or a data lake or something like that, you still have another move that you have to make with data. So when I said that space is interesting right now, it's because there's a lot of other technologies that are coming out to try to help solve that problem. And I do think that's a place where Apache Kafka could innovate and help the users of that solve that problem, because we're only getting more and more data coming at us faster and faster.
Yeah. Well, and I think that brings up a good segue into the fact that Kafka is not an end all be all application. It doesn't solve everything, right? It's just one piece in the cog, or one cog in the giant tool here. And so data's coming in, whether it's from IoT devices or end user applications or whatever, it's coming in to this messaging bus. Um, what integrates with this? Like we've talked about Kafka. You talked a little bit about ClickHouse there for analytics and things, but like, what does this look like big picture when we kind of zoom out and go, okay, Kafka to what, or how does this kind of fit in with everything else?
Yeah. So the reason Kafka won the API battle is because of the ecosystem. It's because of the community. It's such a powerful tool that um, the community has really rallied around it, and there are hundreds of connectors out there. And what a connector does is it's part of the what's called the Kafka Connect framework. And so the connector will essentially allow you to consume from an Apache or from a Kafka topic, and then produce messages to whatever your destination is. So that in the world of data streaming, it's often called a source and a sink, right? So your source in this case would be Apache Kafka, and your sink, let's say, could be a ClickHouse, right? Where you would actually push the data from Kafka to ClickHouse. In addition to that, you can go backwards, right? So if today you've got a relational database and there's a couple of tables in there that are like critically important for you, and maybe you're streaming messages in and you want to enrich those messages, but you need some data from one of those other tables, you can actually use a relational database, let's say a Postgres or something, as a data source, and you attach to the change data capture events that happen, and those events then trigger events to happen in Kafka, and you can kind of materialize that the topic in Kafka as a table, and so then as the data is flowing in, you can join them together and produce new events in Kafka with your enriched data set. So it's kind of like an ETL, but it's on the fly using data from other sources. And that ecosystem is really, really rich.
So, for somebody, just to kind of summarize here, somebody looking at building or using Kafka in their environment, we've talked about kind of sizing, we've talked about scalability, we've talked about data storage, right? We've talked about integrations with the ecosystem. Are there any gotchas or any like final messages, words of wisdom that you would give to somebody who is looking at using Kafka for the first time, and maybe a little terrified or overwhelmed by everything that they have in front of them? What is your message to them?
Um, I recently heard this term called vibe coding, right? And I would just say, don't be vibe coding for sure. So just because you hear Kafka and you think it's a hot thing, don't pick it up just because of that, right? Evaluate it, look at it, and see if your use case is going to work well with that technology. If you really think that's gonna solve it, and a little plug here for the Instaclustr team. So, our group, we've got consultants. We got myself as terms of a solution architect, and then we've got a managed platform and also a support mechanism. So, if you have a use case and you think Kafka might be good for it, our team can help really look at your use case and identify if it makes sense, right? And that's something that we do all the time. And we have customers that come to us and ask us those questions. And if we think it's the right use case, we can help you design it, right? We can help make sure, okay, this is the way that you would achieve that. Here's the gotchas in that process. Make sure that you're using a dead letter queue, so that way your entire your hot happy path doesn't get messed up, and you're shuffling messages off to a dead letter queue. Stuff like that are things that are uh, they're really felt through experience, and our team has that experience. So I would just say, do a careful evaluation before you dive in head first.
Awesome. Andrew, thanks so much for joining me today. This has been great. So thank you so much.
Thanks, Brian. I appreciate it.
For everyone else, if you're still here, we're grateful that you followed us, that you watched this. Go ahead and subscribe, and we will catch you on the next episode of InstaBlinks. Have a great one. See ya.
See ya.